Today we're going to look at fractional and negative indices. And the first thing I want you to do is see if you can fill in the question marks on each of these little equations. Like some of them might have more than one answer, so have a go now. Okay, so first one, you have to add the powers. It's going to be 2 to the 7. Second one, we're going to minus the powers, 7 minus 2, it's going to be 3 to the 5. This one here, okay, this is just testing whether we understand these rules then, so I'm going to add two numbers to give 12. So I could have 6 and 6, I could have 5 and 7, 7 and 5, 10 and 2. Actually, I could even have something like 1.5 and 10.5. That still follows the rule we've used, even though we've not really discussed what raising to the power of 1.5 is. This one, okay, so I've got 3 question marks now. Just need to realize that I am minusing two numbers to give another number, so it could be 5 and 1, and then that will give me 4. Could be 8 and 3.5, and that will give me 4.5. Okay, all these, lots of possible answers. Here we're just testing our knowledge of this kind of power rule where we multiply the powers together, so that's going to be 2 to the 6. Here, okay, how are we going to do this one? Well, I'd probably write it as 2 squared first and then raise the power of 4, so I can see then it's going to be 8. Another way you might have done it would be to have written it as 2 to the 4 times 2 to the 4. That is another rule that you can use for when you've got these brackets. That's how you expand these brackets. And again, we'd get 2 to the 8. Okay, this last one, we're just looking for pairs of numbers that multiply to give 12. So 3 and 4, 2 and 6. You could even have 24 and 0.5. So these are some possible answers. Okay, we're going to so we've talked about negative indices already. I'm just going to quickly run through that to recap it. So we can simplify it. This is going to be quite quick, but we can simplify this as 1 over x. We can use our rules of indices here to give x minus 1, and that is telling us that 1 over x is x to the minus 1. This is 1 over x squared. This is x to the minus 2. That's telling us that x to the minus 2 is 1 over x squared, and we talked about how in general 1 over x to the n is x to the minus n. Similarly here you get x to the 0, and that is equal to 1. That's another one to be aware of. Okay, now we're going to look at fractional indices. On the right, I'm going to continue to just use the rules of indices that I know. So I know that this is going to become 2 to the power of a half plus a half. That's going to be 2 to the power of 1, or just 2. And then on the left, I've got the square root of 2 times the square root of 2. But by definition, that's equal to 2, because like the square root is what you times by itself to give the number inside the square root. So the square root of 5 times the square root of 5 is 5, and so on. So what does this tell us? It tells us something very, very important. It tells us actually that the square root of 2 must equal 2 to the power of a half. That is, if I raise something to the power of a half, I'm actually just square rooting it. If we understand the definition of a square root, and we accept this rule of indices that we've used before, then it must be the case. Okay, what about here? 5 to the third times 5 to the third times 5 to the third. We're just going to add the powers together here, and again we're going to be left with 5 to the power 1, because a third plus a third plus a third is 3/3 or 1. And then the definition of a cube root is a number that I times by itself 3 times to give me the number inside the cube root. So again, this is going to equal 5, and this gives us another result that is going to be really useful. Actually, if I have the cube root of 5, which I put a little 3 there, that is equal to 5 to the power of a third. Okay, I'm not going to do any more sort of calculations like this, but what do you think I would write down for the 4th root of 7 if I want to write it in index form, that is 7 to the power of something? And the answer is that it would be a quarter, because in both cases, if I times 4 of these together, 7 to the quarter times 7 to the quarter times 7 to the quarter times 7 to the quarter, I'll get 1. I'll do the same over here. And the final one then, what about this? What if I have x, the nth root of x? Now if we follow the pattern, we've understood this, this is what we would write down. Okay, and this is our key result for today. We can now find fractional powers of this form. Okay, n's typically a whole number, it could be 5, 6, 7, whatever. We'll be taking that root of x. And we can extend this a little bit more, because if we combine this here with this, 1 over x to the n equals x to the minus n, we can just do one other little thing. Okay, we could write down that x to the minus 1 over n is 1 over the nth root of x, and actually that is an equally powerful result for today. So I'd say this here, absolutely crucial, along with this one. These are results for today. Okay, let's put that into practice with 8 examples. So as long as we understand these 2 results above and we know how to find roots, we're going to do all of this without a calculator, then we can solve these questions. So let's do this. So 4 to the power of a half without a calculator is going to be the square root of 4, which is 2. Okay, 4 is a square number, 2 times 2 gives us 4, so the square root of 4 is 2. This 27 to the power of a third is 27, the cube root of that. Now, you might know your square numbers or your cube numbers really well, you might not. If you don't, then you're going to have to think, what kind of thing is that going to be? Well, it's going to be a nice whole number if you're being asked to do this without a calculator. So we know that 2 times 2 times 2 is 8, that's too small. Let's try 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. That works, so the cube root of 27 is 3. And the same idea is going to be for this one. You might not know your powers of 5 for like all your different numbers, 2 to the 5, 3 to the 5, 4 to the 5. But let's start with the simplest one, 2 times 2 times 2 times 2 times 2. Actually, that is 32. So the 5th root of 32 is 2. We get on to a slightly more complicated one now. It's sort of linking back to the starts that I spoke about with this. Okay, and I said that you could basically raise 2 to the power of 4 and times it by 2 to the power of 4. That's what I wrote down here. So we're going to do the same thing applies here actually. It's going to be 100 to the half multiplied by x squared to the half. And then that is going to become the square root of 100, which is 10. And then I'm going to multiply the 2 and the half together, and it gives me 10x. So I can simplify this, and it simply becomes 10x. I hope that makes sense. Right, 4 more examples. Now introducing negatives. It's okay. Just take it step by step. Deal with the negative first. It's going to be 1 over 16 to the half. Then that's going to be 1 over the square root of 16, which is 1 over 4. I'm doing some parts a little bit quicker now, but I'm explaining it verbally as I go. This next one, deal with the negative first. 1 over the 8 to the power of a third, which is the cube root of 8, and that is 1 over 2. This one, we're going to need to, I'm going to come down here, we're going to need to do what we did here. It's going to be 25 to the power of minus a half multiplied by y to the 4 all to the power of minus a half. Notice I'm putting a bracket in here. That's good practice. Okay, this is going to become, I'm going to do this quickly now, 1 over 25 to the half, or 1 over square root of 25 is going to be 1 over 5. Actually, this is probably the trickiest bit to deal with, because once you get to this bit, we know we just multiply the powers. This is going to become 1 over 5 times y to the minus 2. I could actually simplify this. I could write it as 1 over 5 times 1 over y squared, or 1 over 5y squared. But I would accept this as an answer in index form. I'm just sort of talking about how we could simplify it. Okay, I'm going to need a little bit of room now for this last one. Okay, this last one. Suddenly we've got 3 things inside the bracket, but we're going to deal with it the same way. It's going to become 49 to the minus a half times x to the minus 2 all to the minus a half times y to the 6 all to the minus a half. Yeah, bear with me. Minus a half times y to the 6. Okay, this is going to become 1 over square root of 49. It's going to be 1 over 7. This, I'm going to multiply these two together. Minus 2 times minus a half is just going to leave me x to the 1, or just x. And this one is going to become y to the minus 3. Yeah, I need a little bit more room again. I'm going to delete this. We're nearly there. Like, to be honest, you could leave it like that. I'm just going to, again, show you that we could tidy this up. 1 over 7 times x times 1 over y to the 3, which would become x over 7y cubed. This is sort of an extension bit, to be honest, being able to convert from this sort of index form to fractions, and vice versa, to be honest. The main teaching points then are these ones in boxes here, but understanding why is equally as important, because it's very easy to just forget in a few weeks or months what this 1 over n is and why it's working. We've sort of shown that it's consistent with everything we know in maths, and so we've then accepted it, and we then added this negative from previous just to make sure we can even go as far as writing this result down. We've done some examples, basically going from index form to the number. You might be asked to go the other way. You might be asked to write this in index form, and then we've looked at brackets where you have to sort of essentially expand it first, but not expanding in the same kind of way that when you multiply brackets together, we're raising 2 things inside a bracket to some power, so be careful with that.